Calibrite ColorChecker Passport Photo 2 Review. Color is one of the hardest things to get right, and while the automatic white balance in cameras is decent, it's not as good as using a reference point. One solution is using the ColorChecker Passport Photo 2 by Calibrite that I'll review in this video. Physical design and features. The Color Passport Checker is a little plastic passport-like thing with a bunch of colors inside that act as a standard for color. It does have a middle gray and white balance target as well, and there's a creative enhancement target. This creative enhancement target gives you 2 rows of warming and cooling patches. They allow you to set the white balance warmer or cooler compared to using pure white, so you can quickly achieve consistent effects. And there's also a patch of grays at the bottom with a 1/3 stop difference between them, except for the last one. This row allows you to better judge your tones and analyze how you're creatively manipulating your tones in comparison to reality. At the top, you've got 8 hues to assess color shift, which you can compare to your photo. Finally, it comes with a lanyard that makes it easy to carry it around with you on your photo shoots. If there's anything I'd improve about the physical design of the device, I'd say it was the hinges. On the plus side, they're designed in such a way so that it can be opened at various angles and stay relatively stiff so that it won't move for sure. The only downside is that it does make a fairly loud cracking sound when you open and close it. I haven't had any actual problems with mine, but the cracking sound is a little disconcerting. What is it for? The idea with the Passport Photo 2 is that you can first take a test image under the same lighting conditions as your general photo shoot. This test image should contain the passport photo in the image directly under the main light source. Then, you can use either the Calibrite calibration software or tool in your own program to generate an accurate color correction matrix that can be applied to the rest of your photos in the photo shoot. Here, I'll take the profile I just generated and apply it to another portrait. I made 2 copies so you can see the results before and after. Of course, you can also just use the white balance target to quickly adjust for white balance if you don't want to generate a full profile, but typically the full profile will be more accurate. Here, I just want to show you an example of the use of this thing so you can approximately see the size just to set the white balance in video. Now, ideally, you're going to want to use this thing with the custom white balance in your camera, not set it in post. I'm just going to set it in post because it's easier to demonstrate, but most cameras have the ability to set a custom white balance target, so you can use this thing. Here's the normal color chart, and then I'll show you the white balance target. Here's the middle gray and white balance target right here. So the idea is to put it as close to the main light as possible. So you can see that this is just the standard white balance of the camera, and here is the white balance after I correct it in post with these things. Accuracy assessment. I tested 2 of them under the exact same lighting conditions. A strong, direct flash diffused by a shoot-through umbrella with the flash positioned on axis in between the 2 color checkers. I then measured the hue of each square using an average hue process, and here are the results. I omitted the grayish squares since they are supposed to be colorless. You can see that the hues are pretty close across all patches. There does seem to be an increasing trend here, which may indicate the non-uniformity of the color output of my camera flash, which of course will affect some colors more than others. The largest difference was one of 2.51 degrees. Here's a side-by-side comparison of that square, so you can see the difference. Another problem with this test is that the lens may not represent uniform color throughout the image, so the next test is a little different. This time, I took 2 different pictures with each target roughly in the same area of the frame, and then I corrected for white balance using the same square on each target to account for variations in color temperature of the light across the frames. For this test, I also used my Godox video light instead of my flash. Then I measured the hue, and these are the results. The results were similar, with the colors being fairly consistent with both charts. There were some odd differences too, which could indicate a slight difference in color interacting with the specific lights I used. Here are the differences plotted against each other. If we run a linear model with one difference against the other, we see that the p-value for the effect is 0.029, suggesting that there may indeed be some slight variation between the 2 charts. But the absolute value of the effect is also negative, and the adjusted r-squared is only 0.2185, suggesting also that the correlation is not overly strong, and therefore the differences I measured possibly have a lot of interference with the lighting I used. But after all, we shoot in imperfect lighting, so how can we understand these results in practice? To do this, it makes sense to compare the final color correction matrices resulting from the color correction process. Here are the 2 matrices, and here is the difference. Since these ultimately are used to generate the final RGB values of each pixel, you can see that the differences between the 2 correction matrices is quite small. Finally, by using the middle 4 squares that are supposed to be colorless, I corrected for white balance and measured the final result of temperature and tint. The temperature differences and tint differences are shown here. The tint difference is really negligible, and the maximum temperature difference was measured to be 103 degrees. To get an intuitive idea, here's the same image with identical edits, except that they are 103 Kelvin apart. As you can see, it's a very small difference. Also, keep in mind that in practice, when you're actually using this device, small differences in placement in real-life lighting conditions is very likely to result in a difference of 100 kelvins easily. Therefore, in my opinion, the differences in color hue between the 2 copies I have in practice is negligible, so you can be sure to have consistency using it. Conclusion. If you're a photographer and you want accurate colors as a starting point for your more creative edits, the Calibrite ColorChecker Passport Photo 2 is a crucial device, especially if you want natural skin tones and a consistent look throughout a long sequence of photos. Its consistency of color reproduction is good and means that software designed to calibrate using one will give the expected results. I recommend the ColorChecker Passport Photo 2 from Calibrite. Thank you for watching, and I'll see you again next time.